Hello, welcome to this video. In this, we are going to solve the question 438 of Leetcode. Find all anagrams in a string. The question says, given two strings S and P, return an array of all the start indices of P's anagram in S. You may return the answer in any order. What is an anagram? Firstly, let's try to understand. So you are given S and P, and an anagram is a word or a phrase formed by rearranging the letters of a different word or a phrase. Okay, so let's take an example. You're given the string ABC, and the this is P, and this is in S. You have, let's say, a larger string, whatever, ABC. So basically, uh, what it should be something like, if S contains CBA, so that means uh, P is an anagram. So basically, in an anagram, the when you compare the two strings, two things need to be kept in mind. The letters should be same, and also secondly, the frequency of those letters should match. So in this case, A is present in S one time, yes it is present. B one time, C one time, hence it is an anagram. Second example, suppose there is a CC, and let's say the string in S is something like this. So basically, even if you rearrange it, if you just sort P, so it will be something like ABCC, and now if you sort S, it will be something like ABCC, right? So now when you see these two both are equal, the strings are equal, hence it's an anagram. So basically what we could understand is the letters and the frequency of those letters should match, hence we'll call them as anagram. Okay, order can be any. Okay, need not that they are in an assorted order. So let's quickly move to the algorithm part, and take an example, and let's try to solve this. So what we have is, let's take the example, this AB. Okay, so you have S as AB, and P is equal to AB. So what essentially we want to do, that uh, we want to find all those indices, we want to store those indices who contain AB or either BA. So what can be the possible uh, substrings that we want to search in S? It can be either AB or it can be BA, because it's an anagram, right? So now what we will do is, so since this is more going towards in the direction of a substring, we can think of sliding window approach, sliding window technique for this. Like basically, let's start from this first character, and we also know with this that this is a sliding window with a fixed window size. That means we know that the size of window will be length of P. So length of P is, in this case, let's say 2. So we know we'll start from first character. Okay, we'll just check. Okay, the first two characters, AB. Is this an anagram of AB? Okay, yes, these two strings are equal. They both have the same letters, and also the letters have the same frequency. So hence we can say we have to store the index. So index of A is starting from 0. So in the result, what we will be storing is, we'll store 0. Moving on. Now now just the size is 2 only. Now we'll, from starting from this index, we could cover till only this point. Now let's move from A to here. Let's move the left pointer to B and the current pointer to A. So basically, I hope we know that in sliding window technique, we'll have two pointers. We have a left pointer and we have a current pointer. That's what I'm talking about. So now let's move here. Left is at B and current is at A. Now you compare. So BA is also an anagram. Yes, you see. So that's why we also store the index as starting B is as 1. Cool. Now let's move further. Now when you find the anagram, so you means the window size is done. You have to move ahead. You have to move the left pointer as well. So left increases current increases AB. So you find again AB is there, so 2. So this is basically the approach that we are going to take up. So here, what we could establish or make out the points is that we want to store the frequency of P in a dictionary, right? And we have to the window size will be equal to the length of P, correct? And also third thing that we would want to see is that basically just step by step, one at a time, we want to compare uh, adding one character, removing, adding one character to the right, removing one character from behind, and checking if they meet the condition. Basically, if the if the count, or how do you say, the maintain the frequency of the characters and the what all characters have occurred, we'll use a dictionary obviously. So what we can say is, if the dictionary of count of letters of S is equal to the dictionary of P, that means this condition is met, the anagram condition is met. That means at this point of time, we want to, let's say we have an result answer, we want to store it in the answer variable, the index, and the current index is, let's say, I. I hope this was clear, and this was the basic algo that I'm going to talk about. Let's now let's jump to the code part. So what we have here is, first, as I said, we are having a dictionary. We are storing the count of each letter of P and the frequency. So this counter is basically doing the job for us. So there is a dictionary P. Now we also want to maintain an answer list. This will be storing all our indices as and when we come across. Now the next thing is, how are we starting here is that we are also creating a dictionary S, as I mentioned, which will be storing the count, but just of the length of the counter of the length of P characters. So let's say P is ABC, so length is 3. So starting from 0 till 3, we are just storing their count, because the window size is P, and we are hence we are doing this step. So now we check that if the dictionary of S is double equal to P. Why is this condition? I told you, because this is for checking the anagrams. So if this is true, then we'll store the index 0, because we have just started out. That's the reason we are storing index 0. Now let's move. So now see, let's say we are taking this example ABC. So ABC we started, we compared with this particular part. So is this anagram? Yes, no, whatever. If in this case it is no, so we'll not store. But now we want to start from which index? We want to start from, this is length of P is 3, so this will be 0, 1, 2 and 3 from E, correct? So that's the reason I've mentioned here, start from length of P until where do we want to go? We want to go till the end of S. So I hope the start and end condition is clear. Now starting from E will end till D. Okay. So first, this particular part is very simple. This is basically checking that if this character S of I is present in the dictionary of S. If it is not, then just have equal to 1. If it is present, just double plus 1. Now what we want to do, we just want to now here check that we just first add the character to the current dictionary. So what we are doing here is that we are just adding the character to the current dictionary, and also we are removing one character from the left end of the dictionary of that. So we add E, but we remove B. So now the current substring will be BAE. Okay. And now based on this, we just compare if the dictionary of S is equal to P, and hence we add current pointer minus left plus 1, and then we return. The time complexity of this will be O of n.